Мы наблюдали это с расстояния 70 километров. Какое-то количество людей находилось ближе. Одного солдата, находившегося в канаве, засыпало песком, и один солдат погиб. В одном из близлежащих сел население было все выведено из зданий.
Взрыв выглядел из города Курчатова, центра Семипалатинского полигона. Ослепительная вспышка и ударная волна сотрясли город. В домах вылетели все стекла. Это кадры из фильма, который был снят специально для показа руководству страны. Текст, естественно, читал Левитан.
Вернемся в городок полигона. Сейчас и сюда подойдет ударная волна. Вы видите группу людей, стоящих на дороге? Находясь далеко от места взрыва, они чувствуют себя спокойно. Но за это благодушие им придется поплатиться.
Britain fires its first H-bomb to join the United States and Russia as ranking atomic powers. The thermonuclear device was fired high over its target in the Christmas Islands, keeping fallout at a minimum. But the test added heat to the mounting debate over the safety of atomic tests and came to on the eve of renewed disarmament talks between Russia and the West. With a limitation on further atomic tests increasing in possibility, Britain has staked its claim to full status as a nuclear world power, perhaps none too soon.
In the picture we are about to see, we must remember that the explosive power of atomic bombs used in this test was in the kiloton range. The explosive power of today's hydrogen bomb is measured in terms of megatons. What does that mean to us? It's a matter of practical application. It takes 1,000 kilotons to equal 1 megaton. And by applying the scaling laws, the proportionate comparative effects of a larger bomb can be determined. The A-bomb exploded here was rated at approximately 30 kilotons. For comparison, let's use a 20 megaton H-bomb. The 20 megaton bomb, therefore, would be 667 times as strong as a 30 kiloton bomb. The relationship between distance for any given pressure and the size of nuclear weapons follows the cube root scaling law. So theoretically, a hydrogen bomb of 20 megatons at approximately 8.5 miles would have about the same destructive power as an atomic bomb of 30 kilotons at 1 mile. In this test, many of the structures were approximately 1 mile from ground zero. In the case of a 20 megaton H-bomb explosion, most of these structures undoubtedly would be obliterated. And actually, at a distance of 8.5 to 9 miles from ground zero, with the longer duration of blast pressure, we could expect to find conditions even more severe than those at 1 mile from ground zero in this test. This atomic test although depicting the severe effects of a nuclear weapon, does not reflect the extent and severity of destruction that would result from a nuclear weapon in the multi-megaton range.
At the Atomic Energy Commission's Nevada test site, I covered the story of Operation Q, a program to test the effects of an atomic blast upon the things we use in our everyday lives.
Operation Q, the atomic test program of the Federal Civil Defense Administration, as seen by June Cowan, reporter.
I had to see Operation Q through many eyes, not only my own, but as a reporter through the eyes of the average American man and woman. I arrived at Civil Defense Headquarters the day before the explosion was scheduled to take place, and checked in at once with the official who was to brief me about the test. To give me a perspective of the entire layout, a member of the Civil Defense staff showed me a carefully prepared model of the site. The scope of the test and the detailed care with which it had been planned amazed me as I listened to the explanation.
We begin with the question of shelter, for shelter might save our lives if we were far enough away from ground zero. If so, what kinds of shelter are effective? Several kinds are to be tested, from elaborate industrial shelters to the box-type shelter in the corner room of a basement. This type would give more room for a family, especially if it were necessary to remain there for several days. In this frame house without a basement, at the 4,700-foot line, we will test a bathroom shelter built of reinforced concrete. The entrance door and outside window covering are designed to resist blast.
I asked about the possible loss of utilities and what this would mean to survivors. No electricity for running a home or an industrial plant.
Loss of power may be one of our biggest problems after an attack. Power poles, power lines, pole transformers, and complete substations are to be tested by the Edison Institute. How will they withstand this blast? How long will it take to make repairs? How soon can service be reestablished? These are things we hope to learn from the test. One complete transformer substation has been erected relatively close to the shot tower. A second substation and power lines have been placed at a much greater distance from the tower.
Thinking about news during an atomic attack, I asked about radio towers.
Two kinds are to be tested. One tower is self-supporting without guy wires. The other has supporting cables. Both types are very common. Nearby, a complete radio transmitter will actually broadcast from tape before the shot to be picked up by radios in the test houses. Both liquefied petroleum and natural gas facilities will be tested. Will the fittings and connections stand the test? Will there be fires? All equipment is installed and checked by technical experts from the LP Gas Association and the American Gas Association. An 18,000-gallon supply tank, partially filled with propane and complete with feed pipes. A weighing and storage house and delivery platform have been erected on the test site.
I was anxious to learn all I could about the various types of houses to be tested.
5 types are prepared for exposure to the blast and heat of this atomic explosion. First, a single-story frame rambler without basement built on a concrete slab. Second, a 2-story masonry with basement constructed of brick backed with 4-inch cinder blocks. Third, a house of 8-inch concrete blocks reinforced with steel. The 4th type is a single-story rambler made of precast lightweight concrete. Walls and roof panels were joined by welding steel lugs. The fifth, at the 5,500-foot line, is a redesigned house similar to one previously tested. This new design provides additional strength at a cost increase of approximately 10%. That's the real purpose of testing these houses, to find their weak points. Through the cooperation of the furniture and appliance industries, household furnishings were installed in the houses. Mannequin families supplied by private industry are to represent Mr. and Mrs. America.
Interior home furnishings donated by industry are complete in every detail. I looked at the mannequins sitting about so indifferently. Naturally, I was very interested in preparations for the testing of textiles and synthetic fabrics.
Rows of mannequins were set up in the open facing the blast. Each item of clothing and each color had been carefully selected to give much needed survival information.
I was especially interested in the food test program. Canned and packaged foods are to be tested. As a mother and housewife, this appealed to me. I had several questions to ask. Would food in the average home be safe to eat after a blast?
Food testing in Operation Q is planned to answer this and other vital questions. Some foods are to be tested in the house, stored in the usual way. Other foods, including fresh meats, butter, and similar perishables, are to be tested just below the level of the ground at 3 positions along the main test line. This will expose the food to high-intensity radiation without risking destruction of the containers. Test items include sterilized foods packaged in cartons, metal, and glass. All will be exposed according to plan to give us the most survival information.
The night of the actual explosion, or rather early in the morning, came at last. On Media Hill, television equipment was ready to bring the test into homes from coast to coast. Reporters, commentators, military and civil defense observers all had a purpose: to study the results of this explosion. At a position a mile forward from Media Hill, the Civil Defense Field Exercise Group had assembled with their equipment. A small group of civil defense volunteers were to occupy a trench relatively close to ground zero. On Media Hill, where I remained, there was hot coffee, last-minute briefings, and more waiting. But it seemed no time at all before the loudspeaker warned,
H-minus 1 minute. Put on your goggles. Observers without goggles must face away from the blast.
On the silent desert, the test objects waited.
H-minus 10 seconds. 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
Elapsed before we were permitted to view at first hand the results of the explosion.
Let's see how the blast affected the houses. This is what remained of the masonry house that was not reinforced. This is the house constructed of reinforced concrete blocks after the explosion. Although the redesigned 2-story frame house was severely damaged, the structural improvements had strengthened its resistance considerably. As seen here, although basement shelters offered some degree of protection, they cannot be depended upon completely in potential blast areas. The reinforced bathroom shelter was standing intact beneath the ruins of the house, so this type also offered some degree of protection. The upper section of one unguided radio tower collapsed from the tremendous force of the blast. The guide tower was slightly twisted by a power pole which fell across one of the guy wires. Within the concrete radio house, equipment had been shaken up, but as soon as power was restored, the transmitter resumed broadcasting. The 18,000-gallon tank of liquefied petroleum gas was undamaged. Tests showed that even the connections were intact. The weighing and storage house was scattered across the desert, but the consumer-sized tanks were unharmed. Power lines and transformers suffered some damage, but most of the power poles were still standing or could be repaired. The power substation was not seriously harmed. Edison Institute personnel tested all lines and found the station to be operative. The food and cases of canned goods were taken away for laboratory tests.
Do you remember this young lady? This tattoo mark was left beneath the dark pattern. And this young man, this is how the blast charred and faded the outer layer of his new dark suit. During all this activity, the mass feeding group was improvising to feed the test observers. I particularly remember some roast beef. It was done to perfection and roasted in cans which could have been salvaged from demolished buildings. I watched the people eating and realized that mass feeding is an important job in civil defense. I took a last look at the debris and devastation. This time it was only a test, a well-planned test, not a real attack. It was a test of the things we use in everyday life.
Many lessons were learned from this test that affect civil defense planning. And it must be borne in mind that multi-megaton weapons would result in much greater damage over a larger area. All these factors must be considered as we plan for the survival of our homes, our families, and our nation in the nuclear age.